Define what is meant by a metallic bond. You can't just say it is the bond between two metals. You're in grade 11, you need to be a little bit more specific than that. You need to talk about the positive kernels and the sea of delocalized electrons. You then need to say, with the aid of a diagram, explain how the bonding of metallic aluminium allows for it to conduct electricity. They were specific about aluminium, and most of you didn't answer very specifically with aluminium. What happens with aluminium is it becomes 3+, and it sticks 3 electrons into the sea of delocalized electrons. So, in an ideal world, if they're going to give you aluminium, best you actually use aluminium to explain your answer. Then what you need to say is something along the lines of the outer electrons, the 3 outer electrons of aluminium, are in the sea of delocalized electrons. These are free to move should a potential difference be put on either side of that conductor. So you need to explain how this bonding allows for the movement, at least the flow of electricity. Define the term intermolecular force. It is a weak force of attraction between molecules. It's also between noble gases, but really that's sort of a bit of a rank outsider on the story. It's the weak force of attraction between molecules, not between atoms or bonding or anything like that. It holds the molecules together. At 25 degrees centigrade in 1 atmosphere, chlorine is a gas, but iodine is a solid. With reference to the intermolecular forces, account for the difference. Well, what is the difference between chlorine and iodine? The first thing to say is that they are both nonpolar molecules held together by London forces. So you're showing that they're actually very similar. The difference is iodine is bigger than chlorine, therefore has more electrons in cloud, and that means there's greater electron cloud wobble, which creates stronger instantaneous dipoles, or short-term dipoles, or snapshot dipoles. So the lots of electrons creates greater electron cloud wobble, which means that you get a greater polarity in iodine than in chlorine, therefore stronger IMF, which then means therefore higher boiling point, which in essence means it's a solid, and the other one's a gas. The table below shows the boiling points of water and methane. Water and methane have very similar molar masses. So water is H2O, so it's about 18, and methane is 12 plus 4, which is going to be 16. So they really are similar. They should seem very similar. But explain with reference to their intermolecular forces why the boiling point of methane is so much lower than the boiling point of water. First thing is water is polar, covalent. And although methane has got polar covalent bonds, it is a non-polar tetrahedral molecule. That means that it is held together by London IMF. So the intermolecular force is London, whilst water is hydrogen bond forces. Hydrogen bond forces are strong. London forces are weak. That means that water will have a high boiling point, but methane will have a low boiling point. Define the term electronegativity. I think we all got it right this time, which is really, really cool. It is the measure of the tendency of an atom to attract a bonding pair of electrons. That's your definition. With reference to electronegativity, explain why lithium in group 1 on the periodic table forms an ionic bond with oxygen, whereas hydrogen, also in group 1, is covalent. It was nice enough to say one's a metal, one's a non-metal, but they did say you had to use electronegativity. So the EN difference, and it's not just the electronegativity, it's the difference that becomes important between lithium and oxygen, is going to be 3,5 minus 1, which is equal to 2,5. Therefore, that is ionic. However, the electronegativity difference between hydrogen and oxygen is going to be 3,5 minus 2,1, which is equal to 1,4. That falls in the polar covalent range.